Hello everyone, my name is VK Krishna, roll number 20951A2130, branch Aeronautical Engineering, subject Rocket and Mission Technology. So today I want to discuss about the topic reusable vehicles to come to forefront. So first we need to know what is a reusable launch vehicle. A reusable launch vehicle (RLV) refers to a vehicle which can be used for several missions. A reusable launch vehicle is a space analog of an aircraft. Ideally, it takes off vertically on the back of an expandable rocket and then glides back down like an aircraft. During landing phase, an RLV can either land on a runway or perform splashdown. The main advantage of an reuse launch vehicle is it can be used multiple times, hopefully with low servicing costs. The expandable rocket that is used for launching the RLV can also be designed to be used multiple times. A successful RLV would surely cut down mission costs and make space travel more accessible. So this is all about the reusable launch vehicle which can be used for several times, and it can ideally takes off vertically on the back of an expendable rocket and then glides back down and like an aircraft. This is all about RLV. Coming to the history, the thought of reusable launch vehicles started in 1950s, but serious attempts at completely reusable launch vehicles started in 1990s. The most prominent were the MC Donald and Douglas DCX and the Lockheed Martin X-33 Venture Star. This is all about the history, and here we can see the pics or figures of DCX and X-33 Venture Star. Coming to today, SpaceX is a recent player in the private launch market, succeeding in converting its Falcon 9 expandable launch vehicle into a partially reusable vehicle by returning the first stage for use. On 23rd November 2015, Blue Origin New Shepard rocket became the first proven vertical takeoff, vertical landing (VTVL) rocket which can reach space 100.5 km. This is about the today. Nowadays, the SpaceX is a recent player which is successed in converting its Falcon 9 expandable launch vehicle into partially reusable vehicle by returning the first stage for reuse. Coming to the design of an RLV, it consists of body, wings, cockpit, and electrical power. Here I will discuss about each and every part of the design of reuse launch vehicle. Coming to the body has to withstand very high stresses. It has to cope with the rapid change in temperature, which changes from minus 250 degrees centigrade in shade to minus 250 degrees Celsius in direct sunlight. Coming to wings, delta wings provides enough lift to fly to space and also reduce the friction during re-entry. Coming to cockpit has double pane glass windows which can withstand the force of flight, pressure, and vacuum. Oxygen bottles are used to add breathable air. An absorber system removes the exhaled carbon dioxide. Coming to electrical power, the power required is taken from lithium batteries which could be charged if needed by solar using solar energy. This is all about the design of a reusable launch vehicle. Coming to the RLV concepts, stages to orbit. Here we are going to discuss about several stages to orbit. Coming first, single stage to orbit (SSTO) reaches the space orbit carrying small payloads of 9,000 to 20,000 kg without losing any hardware to LEO. Coming to two stage to orbit or double stage to orbit are two independent vehicles with interactions with while launching. Coming to crossfeed, it has two or three similar stages or stacked side by side and burn in parallel. They carry heavy payloads to outer space. Here we can see the figure of retro propulsion or backward propulsion. And here I have designed some figures which describe about mid-air recovery (MAR). Coming to preparing for reuse, how we prepare a vehicle to reuse. Here I am going to discuss. So the vehicle requires extensive inspection and refurbishment. Each and every part of the vehicle, launch vehicle, needed to be individually inspected. For example, the orbiter's thermal protection tiles needed to be individually inspected and potentially replaced. Main engines needed to be removed to undergo extensive inspection and overhaul. Parts contaminated with ocean salt water and had to be cleaned, disassembled, and refurbished before use. Coming to economics of reuse, here we can see the two flowcharts which describe about a first stage cost and second stage cost. Coming to conclusion, reusable launch systems have the highest development costs and technical risks, but the technology is within current state of the art. Current efforts to economically recover and reuse launch vehicle elements are more promising than they have ever been. A reusable system has extremely low direct operating costs. A future reusable launch vehicle should be constructed within low cost. Use cryogenic engine for all the stages. Autonomous reusable launch vehicles are considered to be low cost alternatives. Future RLV are to be developed through an extensive flight demonstration. This is all about the conclusion. Thank you.